अरे आयुष को तो खराब कैसे जाएगा जल्दी योग के पास गया था एक तो पता है मत कर अबे
तो इन्फॉर्म कर तो सोच अरे वो क्या इसको अरे यार पढ़ने
ये ग्रुप बता दे
ग्रुप मुझे आयुष ने मैं तो कुछ पागल दिया मेरे सारे लोग सच्ची में हां
मम्मी का सफाई नहीं लो एकेडमी टाइम में जाते हैं दोनों उसमें तो ये करी ये पिछले 2-3 महीने से लग रहा सर किधर गए
हम लोग अपने ऊपर ही नहीं मामले में ओए आ गया हूँ मैं क्लास में मूव ऑन एक मिनट I'll keep my bottle here just keep the bag inside everything small chapter with lot of portion removed so whatever is remaining is important so given time we'll discuss that what did we start with have I started did I start this chapter or no Sir, is completed so we are here to finish the questions of human eye.
Why do signboards?
Everything is important. Nothing is entire thing which is there in your list. You have an old one or new?
I have
Yeah, I
I'll tell you. So I'll tell you what is there in the syllabus for you. So you have the first article 13.1 which is magnetic field and straight line. Everything and then 13.2.
due to current
Yes. There are so many subtopics in 13.2.
Yes.
All of them. What are we doing till now? Stay sit now. Then 13.2 mein you have magnetic field due to a current circular loop.
Yes, sir.
Due to a solenoid. The entire 13.2.
Straight conductor and circular.
Yes. Then 13.3.
Current carrying conductor.
Yeah, like everything. So it has a law.
No electric motor, right?
No. So till 13.3. After that, domestic electric circuit straight away. 13.7. That's it. Not numericals, but there are laws, applications. Yes. Okay, let's resume UNI's colorful world. We completed atmospheric reflection. Dispersion completed. Recombination. Did we do formation of spectrum?
Yes.
Huh?
Oh yeah.
Oh yeah.
Sir, we did that.
We did.
Yes.
Spectrum is done, right?
Yes, sir.
If you all want to, I can see the diagram. No, this.
Please, sir.
So we have completed in atmospheric refraction till twinkling of stars.
Yes, sir.
Okay, we have completed.
Yes, sir.
Acha, early sunrise.
Yes, sir.
Why do planets do not twinkle? Okay, great. So that means only one topic is remaining, which is scattering of light. Okay? Scattering of light. So, bag you just keep somewhere behind or keep it. So, scattering of light is irregular reflection of light by atmospheric particles. Is irregular reflection of light. Irregular reflection of light by atmospheric particles. Irregular reflection of light by atmospheric particles. Such as air molecules, water molecules, smoke and dust particles. Okay, so what are the particles? Air molecules, water molecules, smoke and dust particles. These are the particles which are suspended in atmosphere. Okay. Now, as you know, atmosphere has various layers: the upper layer, mid layer, and layer close to the surface of Earth. So the upper layer mostly consists of air molecules. Okay. And then you have water molecules and smoke and dust particles. So the size of the molecules is increasing as you're going close to the surface of Earth. Right? So these are smallest size. And this is biggest. So these are the scatterers. So basically you see what happens. If this is the scatterer. So depending upon where the light hits the scatterer, this is the particle, okay? Scatterer. This is scatterer. So depending upon where the light is hitting the particle, let us say it is hitting it here, this case, it will be reflected in this direction. Over here, it will be reflected in this direction. Out here, like this. Can you see the direction of reflected ray? It is not uniform. It's not in the same direction. So this kind of reflection is called irregular reflection or scattering of light. Okay. So depending upon where it is hitting the scatter. There is one more thing. Which colored light will be scattered by what particle? Okay. So there is a rule. The scattering of light color, that is, color is determined by wavelength. Depends on the size of the scatter. Scattering of light depends on the size of the scatter. So what is the rule? If the size of the scatterer is small, it will reflect small wavelength lights. Okay? That means if for small size scatterer, scattering of light is directly proportional to the size of scatter. So if the scatterer is of small size, what kind of color it should scatter? Violet. Violet of blue side. So in spectrum, I told you, in spectrum, we have two parts. So on the right of green, you can say red side of the spectrum. On the left side of green, you can say blue side of the spectrum. So red light dominates on the right side. Green is in the middle. So this side is orangish yellow with pure, right? So this side is dominated by red, orange, this type of color, and here it is blue, indigo, violet. So these are all bluish. Okay. So if the size of the scatterer is small, so this blue side of the color will be scattered. And as the size of the particle increases, it starts scattering other colors also. So here it will only reflect blue and below. On this side, red and everything else. So which color will be scattered in the end? Red. Because the biggest size particle would be required to scatter red color. And they are very close to the surface of Earth. Understood? So red color will be the least scattered color. So just keep these facts in mind. And which is the most scattered color? Blue. So, yeah, violet, what it will appear blue to you because everything appears blue. You don't see the sky as violet, right? It appears blue to you. So as the sunlight enters the atmosphere, which color will begin to get scattered first? Blue color. Violet, indigo, blue. Okay. So you say blue. You either say blue or you say red. Okay. So most scattered color is blue. That's the reason for blue color of sky. Because blue is the most scattered color. सबसे पहले वही scatter होना शुरू होता है. ठीक है? So the reason for as the sunlight enters the atmosphere, the small sized air molecules scatter the light of small wavelength. Which is violet indigo. Okay. The first light which gets scattered is violet indigo and blue. This is the region for blue color of sky. So that's why in daytime when you see towards the sky it appears blue, right? But what about morning time? Does the sky appear blue in the morning? Towards sun it is red, but elsewhere it is still blue. Okay. So, but why the sun appears red in the morning? So the reason for that is, देखो, sun appears red, orange. During morning and evening. When I say morning and evening, it is sunrise and sunset. Why this is so? Now look here. When the sun is rising, let us say sun is here. And this is the horizon of the earth. Right? So in the morning time, the sun rays will travel maximum distance in the atmosphere. Right? So if this is the atmospheric envelope, let us say. So atmospheric envelope is here. Okay. So let us say atmosphere begins from here. This is sun. If the sun ray enters atmosphere, it travels maximum distance in the morning time from here to here. Let us say AB. So the blue light scatters first as it encounters smaller air molecules. Then the bigger wavelengths get scattered. The least scattered color is red color. So only the red color reaches the observer in the morning time. All other colors are scattered. So sun appears red or orangish during the morning. Okay. Now imagine when sun reaches here in the afternoon time. It appears white. So what is the reason? Now look at the distance traveled by the sun ray in the atmosphere. So it's looking same. Actually, can you see this if I make the size of Earth like this? Okay. So this distance will be more. See the diagram in the book. That's appropriate. So the distance traveled, the vertical distance becomes very small. Look here. In the morning, this is the distance traveled. But at noon, the distance traveled through the atmosphere is very small. Okay? So the chance for scattering, the light that travels at noon doesn't get enough chance for scattering. So almost all the colors reach the observer. So when all 7 colors reach together, it appears white. So sun appears bright. Sun appears white. But at noon time also, if you look elsewhere, the sky appears blue only. Only in the direction of sun. During morning and evening it appears red in the morning evening and white in what at noon. Okay, is that clear? So the reason is no scattering during daytime. Why? I just said the distance traveled is so small that the chance for scattering is not enough. Here there is enough chance for scattering. See, when it is traveling, there's a longer distance through the atmosphere. Okay? Just
So when
the
there is longer distance, we'll see red, and when there is less distance, we'll see blue.
yes, the reason is why. Why?
Scattering of light.
Scattering takes place here. There is enough chance, enough time for scattering in this situation because light travels very fast. Okay? So here a lot of scattering takes place. So the smaller wavelength color gets scattered. But here it doesn't get the chance. Okay? So all colors reach simultaneously. Okay? The person appears white itself. Alright. So we have covered both what is the why the red color of sky, why there is blue color of sky. Okay. So since red color is the least scattered color, that is why it is preferred in danger signal. Yes. So it can be viewed from the farthest distance. Okay. Excuse me. All right. So you can read different points given. See if there is any difficulty in understanding any one of them. So we are almost done. Just the Tyndall effect is remaining. I'll explain that. Tyndall effect I covered. Okay, but I'll explain it again so that if there is any difficulty you can understand. So anybody would like to elaborate on Tyndall effect? First read about scattering, then tell me what is it. In?
In the case of concave, when the object is in the it comes here at the positive and converges at the positive. So we say that it is inverted.
Real and inverted.
Real and inverted. Like,
Why do we say real?
real because it is forming like
In front of the mirror. And the rays are physically intersecting. Lens. But you just said mirror. Okay, you're talking about lens, okay?
So when it's talking about concave, like there is a common rule that if it is coming and meeting at the point on the principal axis, it is inverted. But like answer one let me because whenever in the case of concave, it appears to be fixed.
Yes.
So we are seeing virtual and usually we are saying that the virtual and direct are both together. But here it is also coming when you meeting here at principal axis at the point. So can't it be
No problem.
confused?
So you have to understand what is the difference between real image and virtual image. In case of concave lens, it is virtual image.
Because it is forming.
So is it actual rays meeting? No. So when the actual rays are meeting, that's when real image forms. When the actual rays after refraction intersect each other or meet each other, that's where real image forms, and that will be inverted. But in case of diverging, when you see, let's say you're seeing from this side, you are the observer, the lens, the light is coming like this, it is diverged. So what you will feel, these rays in reality are parallel. Okay, but what you will feel that these rays are actually coming from the focus. In reality, they are not. Then it is virtual. It's not real. That's why dotted. Okay, and therefore virtual image will remain erect, upright. So the difference is in the nature of way the real and virtual image form. Clear? So Tyndall effect. Anybody would like to explain what is Tyndall effect? Okay, try.
Tyndall effect is basically the phenomena in which when there are scattered or suspended particles of, let's say, dust in the atmosphere, the light that passes through it gets diffused and scatters away because it hits those small particles and it does not travel in a straight beam.
So what is Tyndall effect?
phenomena of the diffusing of light due to the presence of suspended particles.
So how do you recognize that the light is getting scattered?
Like in canopy.
What is precisely which thing we call Tyndall effect? What you're saying is
Incidence to a very minor place, but then it lights up a larger place. So that is. We can say it can be dense forest plus where from the trees, these are like this.
in this room, how many light sources you can see?
Four.
Four, right? So can you see the light traveling?
No.
What if I throw dust particles here?
We can see
You can see the path of light. When you can see the path of light, that is Tyndall effect. You understand? When you see, right now light is coming, falling on me. You can see me is the fact that the reflected light which is falling on me is reaching your eyes everywhere. But can you see the reflected light traveling towards you? You can't see the path of light, right? So you can see the light only when it interacts with some particle. Okay? So if I throw some, let's say, phosphorus powder like on performing stages, what do? Suddenly you see fog. Fog is nothing but light interacting with those particles, the mist. So in canopy, what you see is when there is vapor or mist, then you see that from the perforation, leaves, etc., when the light is entering, you can see the path of light very clearly. Understood? That is Tyndall effect. So you can see the path of light only when there is a presence of scatterer. Now, why do you white light only? Have you seen, no, in villages, etc., when the sunlight comes through some perforation, you see straight light path you see. So, light path is basically you are seeing the dust particle which are floating in the path of light. Basically, you see the scattered light from the particles. So, you see particles actually. You understand? You understand? So, the path of light is basically the particles of the medium that you are able to see. So then you say, okay, light is traveling through this path. Understood? So that is Tyndall effect. So then you can actually distinguish between solutions in chemistry. So if it is a homogeneous solution, you pass the light, you won't see any path of light through the homogeneous solution. Now keep a colloidal solution. You will see the path of light through it. Okay? So basically you are seeing the particles of the colloidal solution. Okay, this is how you can judge whether the solution is pure, impure, homogeneous, heterogeneous, all those things. So the reason you are able to do all this is because light, the size of the light itself is very small, angstrom, the wavelength. The dimension of light is its wavelength. Okay, so if the scatterer is smaller than that, then you won't be able to see the path of light. It won't reflect any light then. The size of the scatterer has to be equal to the wavelength of light. Some wavelength of light. The smallest is for violet color. If the size of the particle is smaller than the wavelength of violet light, then light will just go past it. Understood? So this is how we are seeing the path of light, and I just explained what is Tyndall effect. Is that clear? What is Tyndall effect?
Yes.
So it's not much applicable for us. It's more in chemistry, but it is also mentioned as one of the effects of scattering of light. Understood? It also is an example of scattering of light, and in this case we are calling it Tyndall effect, when the path of light becomes visible through the medium. All right. So all of you have studied, gone through what is given for scattering of light. Any questions? Okay. Now we'll take up questions at the back. So since we did not do any NCERT in-text questions, we'll cover all these questions. So it will quickly prepare you for everything. So we'll take turn in answering. So what is meant by power of accommodation of I? Raise your hands who want to answer. Power of accommodation of I.
So when your eye adjusts its focal length depending on the distance of the object,
Correct. So automatic adjustment of the focal length of the eye by the voluntary action of ciliary muscle. So all these keywords should appear. How the lens is changing its focal length, due to contraction and relaxation of ciliary muscle, depending upon the object position. So when the ciliary muscle contracts and when it relaxes, yes.
Ciliary muscle contracts when the object is closer and relaxes when it's far.
Yes. So this automatic adjustment is called power of accommodation. Okay. Second, a person with a myopic eye cannot see objects beyond 1.2 meter distinctly. Yes.
It is concave lens.
For myopia,
Concave.
yes. For myopia, it is concave lens. Okay. So explain the defect. What happens in myopia?
No, we can't see the far.
Sir, we can only see the object. We can only see the objects which are near us.
Yes. So myopia is nearsightedness. So near objects are seen, but far objects are not visible. Okay. So how it is caused? Like what happens to eye?
Elongation of eyeball.
Elongation of
Eyeball.
eyeball. So when you see the far objects, where the image is formed? In front of the retina. That is why you require a diverging lens to push the image back to retina. Okay. So this is how you remember it. The eyeball is elongated in case of myopia. Okay. That's my favorite student.
The far point is infinity and the near point of the
1.2
is 2.5. 25 centimeter.
25 centimeter. Okay. So everyone understood question 3? Far point infinity and near point 25 centimeter. Fourth. हाँ बोलो. तो सुसु करने गया था ना. कब आया? हाँ ठीक है बोलो. एक मिनट रुक. पूछता हूँ. Yeah, go ahead, fast.
Sir, I should answer.
Yes.
Sir, the student is having the defect of myopic eye,
Yes.
and it should be corrected by the concave lens.
So is she right?
Yes, sir.
Yes.
Student has difficulty reading the blackboard, means his far vision is not right. Far vision is defective. So you identify the defect. Then you can suggest the corrective lens. बताओ myopia के लिए. Concave. We just discussed. Fifth question, who would like to answer? चलो बताओ. नहीं he is raised hand. The human eye can focus object at different ways by adjusting. So it is
Accommodation.
Power of. Sixth.
Retina.
Yes. Retina. Image is always obtained on retina, irrespective of the object position. Okay? So image distance does not change. Question 7. Yes.
25 centimeter.
25 centimeter. ठीक है. 25 centimeter या meter? Centimeter. ठीक है.
Centimeter and meter.
Question 8. So read the question and answer. Ciliary muscle. So again similar. Question 9. Somebody raise hand, please. 9. Question 9 कौन कर रहा है? ये करेगा. Few hands being raised from the left side. Question 9.
Sir.
बोलो.
So, the focal length of lens required for correcting distance is minus 5.
So in this question, what is given and what are you supposed to do?
I know, but I should mistake first.
Power is given and you are supposed to focal length. So how will you? Correct. Yes. So do that. Focal focal length is reciprocal of power by retaining the same sign. ठीक है? Calculate.
0.6.
So distant vision will be,
0.6.
0.67.
so that is negative or positive?
Positive.
Sir, it's
minus 5.5, so it's negative.
You have to retain the sign of power. Focal length will be negative. For distant vision,
what distance is really positive.
you have to correct the distant vision. Means you are correcting
talking
myopia.
about the near vision.
You are talking about near vision. So what was the power for near vision?
Near vision
Plus
So
0.67.
negative. First answer will be negative. Second answer will be positive. Calculate. Calculate the reciprocal for both.
Second one is 0.67.
So for distant vision, correct. F is equal to 1 by P into 1 by minus 5.5. Answer will be?
Negative 0.1.
0.18.
And here
Negative 0.1.
18 meters.
currently, correct.
Sir, negative 0.18 meter.
Okay, this is what it is. ठीक है, तो ये कितना आ जाएगा देखो. This is
Negative 0.18.
so minus 2 by 11.
So which is negative 0.1. Negative 0.1.
This is minus 0.18
18
meter. So roughly 18 centimeter, right? And this will be 10 by 50. So this is concave. You have to write both, okay? Concave.
So for negative power, it's concave, and for positive, it's convex.
Yes.
Yes.
This is equal to 2 by 8, which is 0.666, which is 0.67 meter. Is it 0.67 meter? Second is 0.67.
I can for the
Meter.
ठीक.
Sir,
Plus. So next, question number 10. Now this is important question. Question 10. Why don't you do question 10 and go? You will miss it otherwise.
So how are we supposed to solve it?
Exactly. That's why I was stopping here. But yeah, yeah.
So 1 upon v 1 upon u is equal to 1.
So now here we are. Far point of a myopic person is 80 centimeter. What is the far point for normal eye?
It is value.
So this is the difference.
Value of u will be like object distance.
This is object distance.
Maximum distance.
What is the correction? Far distance. So what is the correct? What is the correct far point? Infinity. So u should be infinity now. This guy can't see object beyond 80 centimeters. So image should be formed.
Image should be 80 centimeter. Object will be
Yes. So the
and we have
defective.
to find the focal length.
So in such questions, here we are.
Sir, we will use the 1 by v
Myopic
minus 1 by
We're
u.
supposed to see
So U is equal to infinity, V is equal to 80 centimeters.
Sir, we will.
The defective far point is where the image will be formed after using the lens. That's what the eye will be able to see. So for all the far objects, with the help of the lens, the image will form at 80 centimeter, which his eye is capable of seeing. Understood? So that's the logic here. So now this will be the focal length of the lens that we are going to use. So find out.
So take infinity as one.
Infinity is 1 कैसे हो जाएगा? 1 by infinity is 0.
So zero.
So look here, look here.
No, so mean. मेरा formula था.
So object has to be always negative. And image is also forming in front of the lens. So both are negative. So what is this now? And 1 by infinity is always 0. Division by large number will give you a very small number. So infinity is so large that it is 0. Correct? So this is minus 1 by 80 plus 0. Since 1 by infinity is 0. 1 by 0 क्या होता है? Infinity. Not defined. So 1 by not defined is 0. उल्टा. Therefore, f is equal to minus 80 centimeters. So you have to use a concave lens of focal length minus 80 centimeters.
So sir, we can write it like.
Concave. Diverging lens of
Sir, no, we have to take it in meter.
concave lens.
Sir, we will take it in meter, right?
Not required. This is not power. You have to ask the power.
Yes, sir. We don't need to find
Achha. So therefore power is
1.1
Minus 1.25.
1.0.8. 80 को तुमको क्या करना पड़ेगा? मीटर में. So now you get 10 by 8. Which is 5 by 4, which is
Sir, answer is negative 1.25. D.
No, this is the 5.4, right?
So negative 1.25.
What? Negative 1.25.
This is right.
Negative 1.25.
Negative 1.25 diopter.
Yes.
Yes. Got it?
Yes, sir.
So this is concave lens. So in this chapter, only this kind of numericals. You will have to find the power of the corrective lens.
So sir,
And
for the
its
power
type.
we have to write the focal length in meter.
Always. That is how power is defined.
0.8 meter.
Yes. So 0.8 because this has to be converted into meter. When you are calculating power, that's then.
So 1 by infinity is 0.
Yes. I told you don't go to washroom. You didn't listen. Now you have questions. All these are explained. If you divide any number by a very large number, answer will be small number. So infinity is exceedingly large. So the answer will be exceedingly small. Smallest is 0. Okay? Just like one division by 0 gives you a not defined infinity. If you divide any number by 0, the answer is infinity. Yes, this is opposite. Okay? Okay, next. What is next question? So, make a diagram to show how hypermetropia is corrected. Hypermetropia,
Convex lens.
yes, जहाँ पे भी convex lens है वो hypermetropia correction. ठीक. So this we have already discussed. The diagram is discussed in the theory, right? So this one. Yes. Now the near point of hypermetropic is 1 meter. What is the power? Okay. Now calculate the power. Question 11. Question 11. Calculate the power. Just like this question. How many diagrams you will make to show this hypermetropic defect? Three diagrams. One will be
Normal
the near point of hypermetropic eye is far away. Okay? And when you do the correction using convex lens, then the virtual image is obtained at the defective near point. ठीक है? समझ आया? नहीं समझ आया? देखो, if you have this is the eye lens. Let us say this is the normal near point, 25 centimeter. ठीक है? तो hypermetropic का near point यहाँ नहीं होगा, यहाँ पे. ठीक है ना? क्योंकि अगर यहाँ पे रखा हुआ ऑब्जेक्ट हम देखेंगे, so for hypermetropic eye, the image will form behind. This is a hypermetropic eye. So what is the difficulty here? देखो, when the object, so near object seen by this eye is only up to here. If it brings the object closer than this, the image पीछे बन जाता है. So this image will be formed. ठीक है? So near point for a hypermetropic eye. How do we correct this defect now?
Convex lens.
You understand the defect now? So now I want to keep the object here because this is the near point, corrected near point at 25. तो कैसे clear होगा? I have to pull this image back to retina. So I have to converge it little bit more. So I will now put a convex lens here. I will now put a convex lens here. Okay. So now when I put the convex lens here, this black ray which was going up will be converged like this. Okay. It is converged now. Then this will be converged further. So now this is forming at the eyelids. After correction, this. Now when you extend it backward, देखो ये object अभी कहाँ पे रखा है? यहाँ पे रखा है. लेकिन when you extend it backward, the virtual image will be here.
Found other defect near.
So when you draw all the rays in the same this thing, no, different colors. Now you understood how the correction is taking place.
This creates the illusion that the image is far away, so that the image will form at the retina.
Exactly, because this eye can only see object placed here, near object. So lens is now pushing this object back to where this eye can see. The lens is only playing that game. The illusion of placing this object in front of her at the faulty near point. Is this clear? In book they have given it in 3 different ray diagrams. So here the defect is this. This is the defect, the red color. The near point is not at 25. This is the actual 25 centimeter. Normal near point. Is that clear now? So take a snap, photo. Otherwise, book में 3 अलग-अलग दिया होगा. Because I know in book they have given 3 diagrams. One will be other. So yeah.
और ये साइड है, ऐसे लोग सेट कर देते हैं.
If they have
नहीं आओ क्या?
नहीं सर आप आ जाओ।
ऐसे रखो सर, ऐसा दिख रहा है, ऐसे रखो सर, अबे आप ऐसे कर रहे हो।
Okay, this is copyrighted diagram.
सर अपना लाइन नाम सेंड कर
Line कर दो।
अरे सर
Okay, चलो बस one opportunity तूने लिया कि नहीं एक स्टेप? हाँ बस let's go ahead.
sir 64 for the this 25 centimeters the power will be positive 3 diameters.
Okay. So how many of you got the answer for the question? Positive 3 dash. So what is the power of lens needed? Is this correct? Let's check. So your V is equal to minus 1 meter. U is equal to minus 25 centimeter. Did you solve using this?
Yes sir 1/3 minus 1/3.
Everybody got this answer for this lens?
Yes.
All of you got the answer? Okay, ठीक है. Hello, all of you got the answer for the power plus 3 diameter. This question I am talking about question number 11. मिला सबको?
हाँ, power, yes. 3 plus 3
Plus 3. ठीक है. So everybody can calculate it, right? F निकालना है.
zero.
And therefore,
I need
how much you got F? How much you got F?
F 0.33.
How much was this? 0.33 means before that step.
33.3.
Before that, how you got that?
Basically, I got it by 100 upon 100 upon 3 which is equal to 33.3 centimeter. And then I converted it to meters.
Okay, let me do 1 by F is equal to.
I will just add 6 meters then
What is going on? वो मिल जाएगा बाद में, ठीक है? चलो. So quite, I'm just doing this sum. 1 by what is this now? This is 1 by 7. Sit down, sit down. What is the LCM now? 100.
4 minus 1. 3 upon 1.
Okay. So what is power? Therefore, P is equal to 1 by. For power, you have to take focal length in meter. So this becomes what? 100 by 33. So 3 point how much?
0.33.
Oh,
In meters, it's 0.33.
Yes sir 0.
0 कैसे आएगा?
33 answer 33.
3.33. Therefore, P is equal to. So everybody got the answer 3.33. Is it time? So this chapter is, as far as I am concerned, it is over. There are some review questions, some more numericals. We do the numericals and then we start
दो पंप बना दिया मेरा बेटे चीज नहीं पाई कुछ भी यार कुछ भी
फिर से फोटो
हाँ और क्लियरली चाहिए। अरे क्या कर रहा है? पुश क्यों कर रहा है? अरे मत। अरे ठीक है वो।
it was there now
अरे वो बीच में बोल आ गया।